Hi there, my name is Joe Davault. I'll be presenting this evening on the Autonomous Pool Cleaning Safety System along with my team members. I'll be covering the methodology section. We all participated, but myself and Sater focused mostly on the methodology. So there are three parts to my section of the methodology. I'll be discussing the deployed solution, the cloud-based architecture that's backing the deployed solution, as well as the tools and software that we used as part of the system. So the deployed system, the one that's out in the field, consists of a series of sensors. We have a water movement sensor that helps us detect with a slide scale on the side of the pool the amount of water movement that's taking place. We have a humidity and water level sensor, and that's used to monitor evaporation in the pool. We have pH and ORP sensors, which are used to constantly monitor the chemical composition of the pool, as well as motion sensors to help with perimeter security around the pool, things getting into the pool. Each of these sensors is equipped to communicate, but all operate independently and communicate with the back-end cloud environment. Each of these sensors comes with a controller board, a set of sensors, and the ability to communicate via Wi-Fi to the back-end cloud infrastructure. So next I'll discuss the cloud infrastructure. Here's a broad overview of the cloud infrastructure. There are other slides that are covered more in detail by Andrew, so here's a slide here, but again, this is covered in greater detail in the systems architecture section. So the cloud-based architecture uses virtualization to help us scale the resources there. There's a baseline set of infrastructure which can easily be scaled based on the incoming load. All software that we're looking at is set up or must use cloud object-based storage. All data is sent from the controllers and the nodes at the on location site and are sent up through the cloud to the back-end system. The system includes a number of components for filtering and correlating the data, and also determining if certain pieces of data need to be rejected. After it passes through this initial ingester, it's handed off to the cognitive perceptrons, which does some additional interrogation and validating and formatting of the data. As the data passes up, we're continually looking at the data and looking at a set of rules to see which data we actually need to process and which data is not necessary. Any of the remaining valid data is passed up to the official artificial cognitron, which is forwarded to the mediator for final actions. All data is then stored after the mediator looks at the learning algorithms to determine what actions need to be taken, and at the end, all data is stored for future events. Some of the tools that are used, we have we're using the boards, Raspberry Pi boards. We use these because they're better than the Arduino boards. They are slightly more sophisticated, better programming API. We use a number of sensors that I've been identified in the system in a later slide, and we have various components on the board that are used to help. From like Atlas Scientific has components that help us determine pH and ORP. Some of the components that are in the cloud include our cognitive perceptrons, artificial cognitrons. We have a mediator, some learning algorithms, and a number of other components that were shown in the diagram. Not shown here, but there were some pieces of software that we chose not to use, like motion detection above and below the pool. We chose not to use that because we felt that the amount of storage required to handle that level of image processing was outside. There were a number of other components that we felt the same way that we decided to back away from. So in the end, these components were the ones we went with. So if you have any questions, please feel free to email anyone on my team. Sorry about that.